Okay, so the idea here that you want to do is you've got to get this so that it's just a single log before you can do the piece of it that is new. So on checkpoint 6, we got the log base 2 of x minus 4 is equal to 3. Now, it's just a single log, right? Everybody see it's just a single log? One log, written one time. So the way that you solve these problems is that you take it completely out of the log process. Okay? In other words, that part of the test that we did, and some of you didn't do so hot on this, so y'all may need to practice this, is we're going to use the definition of logs, and we're going to rewrite this as an exponential equation. Okay? So it says to us that the base, which is 2, raised to the answer to a log problem, which is 3, is equal to the argument x minus 4. The base raised to the answer of the log problem is going to be equal to the argument of the log problem. So that's exactly right, because 2 to the third is 8. We can add 4 to both sides. X is equal to 12. Okay? Any questions about how to do that? Simple enough. But some of you didn't have a very good grasp of that definition, and you didn't do a very good job of rewriting things out of the log form into the exponential form. The argument, the thing that I'm taking the log of. Okay, look at B. We've got 4 times the ln of 3x is equal to 8. Now, just like before, this works just a whole lot better if I go ahead and solve this so that I don't have any coefficients or anything added on. I just want it with the log on one side, like I did with the exponent earlier. So the first thing I want to do is what? Get that 4 over there. So I'm going to divide by 4. So I've got the ln of 3x is equal to 2. Now, the problem with this one that some people seem to forget a little bit is what is my base when it's an ln? E. It's E. So E to the answer, which is 2, is equal to the argument, which is 3x. Remember, E is just a number. So to solve this for x, you're going to divide by 3. And if you'll hit your E button, and then you just raise it to the second power, get that answer, and then divide by 3. And you'll get an approximate answer because E is an irrational number. 2.46. What? Hmm? Right, so the base is E, so I take the base, I raise it to the answer of the log problem, which is the 2, and that's equal to the argument, the thing I'm taking the ln or the log of. Okay, it's the definition. You've got to memorize it. You've got to practice it. Like I say, a lot of you missed those problems on that test. Anybody else got a question? I mean, I know that y'all had problems with that. I saw it. So I'm just telling you right now, practice, practice, practice on that. Maybe go back to section 3 and look at those ones where it said rewrite in exponential form and do those problems and practice them. Because that's going to mess y'all up on this if you don't know how to do it. Checkpoint 7 is the exact same idea. We just got to do a little bit more to this one because it says to solve this equation. It says the log of x plus the log of x minus 3 is equal to 1. We cannot do that definition idea until I have this so that it's just one log. And I've got log written how many times in this problem? Twice. So I'm going to use the property of logs that was in section 3 that we worked on. And I'm going to rewrite this as just a single log. So what do I do to the two arguments? I multiply them together. So this is the log of x times x minus 3 is equal to 1. Okay? So the base, which is 10, raised to the answer, which is 1, is equal to the argument, which is x times x minus 3. And you can write it the other way. You can put the argument first, and then if you like having your x's over on the left-hand side, doesn't really matter, right? If you like it better, you can write it like that. So that's x squared minus 3x minus 10, right? Because I'm going to subtract 10 from both sides. Why did I subtract the 10? Because I saw it was a quadratic equation, right? How do I solve quadratic equations? Have to set them equal to 0 first, and then I can either factor them or I can put them in the quadratic formula, right? This one factors x minus 5, x plus 2. So x is equal to positive 5 and x is equal to a negative 2 are my two solutions. Now, you do need to be careful when you do this, because we can't take the log of any number, right? Somebody asked me a while ago, and y'all had it on the quiz just a second ago, what happens if you try to take the log of a negative number? It doesn't work. It gives you an error. It is undefined. You can only take the log of positive numbers. So you do need to go back and double check in your original problem before you started working it and make sure all of these answers that you got correct, because that word is extraneous. We do sometimes get something called extraneous roots, right? We didn't do anything wrong with the algebra as we were solving it, but it doesn't work back into the original problem because it's outside of our domain. So that negative 2 is going to give me issues. It's going to give me the log of a negative number and the log of a negative number. So that is not a solution. We have to throw it away. So the only answer that I get here is x is equal to 5. Okay? So just be real careful about that because, you know, that's outside the domain. If I'm working with logs, I can't have negative arguments. I can have a negative number for x as long as when I plug it back into the argument, it gives me something that's positive. Okay? All right. Now, then you get an empty set. Yep, that's exactly right. Check point 8 is ln of x minus 3 is equal to the ln of 7x minus 23 minus the ln of x plus 1. So now I've got 3 ln's. And I've got ln's on both sides of the equation. That's actually kind of a good thing. I'll show you why. What you want to do is just simplify on each side of the equation if you have ln's on both sides. So this side we're going to leave alone. It's the ln of x minus 3. On this side it's going to become the ln of 7x minus 23 over x plus 1. Right? Because it was a subtraction. And so what do I do with my arguments? I divide them. Now, you remember that shortcut method that we had with exponents where if it was a like base and it was being raised to the same power, I could just take the powers and set them equal to each other? Look here. Same logs. So I can just take the arguments and set them equal to each other. That's the one-to-one property that we had that said if the ln of something is equal to the ln of something else. It says if the ln of A is equal to the ln of B. The only way that's true is if A is equal to B. That's what all right, I used M and N. But But what I'm saying here is if it's true that these are equal, the only way that's going to happen is if these two arguments are equal. Okay? So you can just throw away the ln part, kind of. And then I can work with just this and solve this for x. Okay? So, like Aaliyah said, if I have this side's a fraction, I can always just multiply by the denominator, right? So if I multiply both sides by x plus 1, I get this. And then I get through FOIL, I'm going to get x squared minus 3x plus x minus 3. So combining like terms, I get x squared minus 2x minus 3 equals 7x minus 23. Now, how am I going to go about trying to solve that? Everything has to be on one side. So I'm going to subtract the 7x first. And what else? Add the 23. So I get x squared minus 9x plus 20 equals 0. So that all zeroed out. That one factors, right? Can y'all tell me what the factors are for it? You didn't think so. For it to be positive 20, they both got to be negative, or they both got to be positive? Negative 4 and negative 5. So x equals 4 and x equals 5 are my two solutions from the process. Now what do I have to do? Double check back in the original equation. Will 5 work? Yes. And will 4 work? Yes. So I get two solutions. Because remember, all you're trying to do is look to see if it's a positive number. You can double check and make sure that it gives you a true statement, but it will. Unless you think you did something wrong with your algebra, that's a good way to check to see if you type something in your calculator wrong or whatever. If you plug it back into the original equation, it should give you a true statement. Okay? So any questions about how to do logs? That's all there is to it. You either use the definition, or if you get lucky and there's a log on both sides, then you can just pull the arguments down and work with them. But the first thing you have to do is you have to get it so that there's just one log on each side of the equation. Okay? Any questions? All right. And then there's only one thing left in this. There's some application problems. You wouldn't learn how to do this if there wasn't a real-world application for it. So checkpoint 9 tells us that we got a formula in example 9 that we need to use, and my formula is here. Okay. This is medical research has told us that the risk of having a car accident increases exponentially as the concentration in the blood the concentration of alcohol in your blood increases. That's where they get those limits, like if you've got 0.01, if they pull you over and they check your blood alcohol content and it's more than a certain amount, you get a ticket for driving drunk, and if it's more than a certain amount, you just get hauled to the police station because they don't allow you to drive any further. That's where that comes from, is from this medical research that shows how much it changes your ability to make good judgments and to stop fast enough and to keep from having accidents. And that's the formula. That the risk that's involved and how likely you are to have an accident is equal to 6 times E raised to 12.77 times the concentration of the alcohol in your blood. Okay? So, on checkpoint 9, it says we're going to use that formula to answer this question. What blood alcohol concentration corresponds to a 7% risk of a car accident?